Yes, thank you. Thank you for joining today's class. So I once again welcome you the lecture series of electric power quality. So we are in fifth chapter now. So in this fifth chapter, we are dealing with the operating conflicts. So what is the operating conflicts means here? So whenever we are connecting a DC to the distribution feeder, so in load side, so you should assume that, or you should know that what are the different problems that will arise by interfacing these two. Okay, so that will comes under the operating conflicts. Okay, so we can see this conflicts different plans. We are already completed two different conflicts. What are those two? Utility fault clearing requirements conflict. We are already discussed this one. Then also we are already discussed the reclusion. Okay, what is this? Uh, so utility fault requirements as well as reclosing. So what is the meaning of this two? So whenever we are considering this is the source. For suppose source, once again, just 2 minutes. This is a VS. So in this side, at this side, we are connected the DC. So and again we have some loads, different types of loads are there, different types of loads. Okay, different types of loads are there in this one. Okay, so in between here we have to protect these systems. They have to maintain again and again. Once again I draw the some single line diagram, some feeder 1, feeder 2, feeder 2, whatever it may be. Different types of the feeders are there. We are assuming different types of the feeder. So these are the circuit breakers, different types of protection equipment, CB, circuit breaker, CB. So in this one, they have to assume here one recloser and then one fuse here, fuse, again one fuse here. So what is the primary equipment to clear the fault? For suppose fault here. For suppose a fault is occurred in this faded tree, this faded. So what will happen here in this case? So so the nearby fuse or recloser. You see this. This is this one reclosing topic. This one. So first of all, fuse will activate that fault and nothing but activated because of that fault, and then clear the fault. If it fails to that fault, then come to the recloser and then come to the circuit. This is the way. Okay, the fault clear. So once this clearing, so whenever so in this field now we can assume this as a protection scheme. The same protection scheme is employed in this diagram. We are assuming this a DC is connected in this faded 3 also. What will happen when this DC is still connected? Okay, this faded 3, even though there is a fault in that system. You know, so if it's still connected, so what will happen here? There are some damage to this DCs, especially while this DCs we are assuming it as some synchronous machines, and that time, so the synchronous machine may get damaged. So to avoid that one, so we come up with this reclosing concept for this DCs, nothing but so DCs will have the different type of nothing but protective scheme at the same time. So this field is also the some different protective scheme. So separately we can maintain the their own protective schemes. Then only we are going to protect this DC at the same time. This fader also. As we in the last class we are already seeing this some diagram also. Yes, some diagram also. Some diagram. Yes. Yes, like this. So in that time, so reclosing time, the DC will open. DC will open in this time, reclosing time. This is the reclosing time. This is the reclosing time. Reclosing time. So this is in between this reclosing time. So DC must be open. So why? Because that so it is discussed in last class. Thoroughly. You know that, right? Okay. So this is the way you have to protect the DC at the same time of feeder. I once again repeat that whenever we are going to operating these DCs, so without any deviations, without any faults and all other things, you must maintain the a separate protective scheme for DC at the same time. The separate protective scheme for uh, this fader. Okay, this fader, you should maintain the separate protective scheme at the same time. This DC, we have this separate protective scheme. Okay, so then only the DC will able to I mean protect the faults from this external faults from occurring from this fader. Okay, so this is the thing we are going to discuss in last class. So already discussed in last class. But here we can see this. You observe this one. So and reclosing our circuit breaker, reclosing our circuit breaker, and all other things. So how this are operated? The circuit breakers and all other things. How these are operating? How the circuit breaker is operating? So the circuit breakers is operated nothing but open and close. So they are directly they are not directly operating. So these circuit breakers is commanded by some another device. We can call it as relay. Relay will give some instruction to the circuit breaker. Good. Okay. Based on that instructions, this circuit breaker may open or close to clear the fault. Okay, so now see this our third topic in this operating conflicts: interference with the relaying. Which one? Whenever you are connected this DC to that feeder, any of the feeder or any of this distribution system, how this relaying will behave to that system. So what is the operating conflicts of this relay? Whether this relay will work thoroughly, or whether that relay will get any problems while interfacing our this DGs to this feeder or PCC. You can also call it as point of contact. Okay, you can see this very important one. This one is a very important one. So and the next remaining two voltage regulation issues and harmonics were already discussed. Okay, so now see this. So this relaying, very important one. This relaying. So before going to this relaying topic and all, so there are some basic some protective schemes, different protective schemes we are going to discuss, and after we are going with the relaying instruments. Okay, so first of all, see that. Okay, yes, sorry. Now see this. We have the system, some generation. See this generation. See the diagram carefully. Generation. Okay, at the same time you have the transmission. This we can call it as some transformer or bus or whatever it may be, some transmission. Let's see this transmission. See this transmission lines. Then we have this distribution distribution lines. Then after we have some customers, some different types of the customers. This is the loads, different types of loads and all other things. This is the basic structure in the power system: generation, transmission, distribution, and utilization. Utility. Utility. This is the utility, basic structure. So now see this. This is the signal line diagram of the power system. We are going to protect this power system from any of the fault, that may be a foreground fault, uh, that may be of another some external faults and all other things. So we're going to put any of this faults from this power system. So in this for this protective scheme, so for this protection process, a single protective scheme is not able to protect the entire power system. Okay, I mean to say a separate protective scheme is employed for the utility side. At the same time, a different type of protective scheme is employed in the distribution side. At the same time, a different type of protective scheme employed in the transmission side as well as the generation side. A same type of protective scheme is not employed for the or not protected for the entire power system. Depends upon the equipment security as well as that equipment characteristics and all other things. We are going to employ different protective schemes for this different sections in the power system. Okay, so that different protective schemes you can call it as a generated protective scheme, protection scheme, transmission protective scheme or protection scheme, distribution protective schemes, as well as the utility protective schemes. Okay, so this 3 to 4 different types of protective schemes are available to protect this all. So, but generated protective scheme is not able to protect the transmission lines and distribution lines and utility lines. Okay, so that's why so different protective schemes are employed for the different sections in the power system. Okay, so these different protective schemes, what are the main equipments here? So circuit breakers and circuit breakers, some reclosers, some lightning arresters, some different types of the equipments are there. So the basic main equipment is the circuit breaker. We are dealing with this. So in these circuit breakers, the commands is given by the from the circuit breaker. The commands is given by the relays. How this relays is connected in this one? Now see this relays is connected this way. So now see this. Yes, we have some transformers is also there. Transformers we have also the different protective schemes. You can call it as a transformers protective schemes. Transformers also a different protective schemes are there. The transformers are bus. The transformers you can simply call it as transformers. Transformers also we have different protective schemes are employed. Then only you can protect the transformer. So generator protective scheme is not able to protect the transformer. Some protective schemes are matching, like power converter schemes and short circuit and other things. So remaining protective schemes are not employed for, are not suitable for the another cases like transmission, distribution, and utility. Okay, so for this relaying concept, how this relays is sensing the fault and given the commands to this circuit breakers. Okay, now see this different way. So whenever you are connecting this generator protective scheme, so like this is the protective scheme of the generator. At the same time, it is already I mean we are already discussed this topic in I think you are able to know this topic in switchgear and protection also. This is the protective scheme for transmission systems. And next one, you can see this. This is the protective. This is the protective scheme for distribution protective scheme. And the next one, can change another color. So this is the protective scheme for the utility. This is the see that 4 different protective schemes are employed. So for this protective scheme, why I am drawing this one? This is we can call it as the range of the relay to detect the fault. The range of the relay to detect this fault. Now see this. That's why you can draw this like this. The range, the generator protective scheme range is up to this range. It will detect the fault. This transmission is also like that. Up to that range, it will detect that fault. Yes, up to this range, this transmission relaying is detect this fault. So similarly, distribution also. So in this type of protective scheme, an engineer and productive engineer is designed this type of protective schemes. Now this type in this protective schemes in this design of this power system, we are going to additionally add the see that additionally add the DC one distributed generating plants here. Now you can see this. Now we are not going to talk about this three. Yes, this distribution. Yes, sorry, these two are our primary aim. These two distribution or utility whatever it may be. So you can consider it as a distribution productive scheme. How this distribution productive scheme will act while you are adding this DC to that feeder to these lines. So we are not bothered about the transmission as well as generation. So because our main concern are mainly we are adding this disease to this transmit sorry distribution side only, distribution feeders only. So now see this. So we have this distribution. Now see this relaying distribution relaying. You have to see this distribution relaying. This distribution relaying. So what is the behavior? So while adding this DC to the one, so we have to see this one. So sorry. So this will comes under this interference with this relay. Okay, you can see this. We are primarily we are discussing three different ways to approach this distribution relaying. Okay, what are the three different categories and three different types? Now see this. There are three major common cases where DC can be interference with the work on production relay and distribution failure will be examined like this. So we are discussing now see this according to your syllabus and all other things. We are considering only one productive schemes. As I said, there are different types of productive schemes for each generating productive scheme as well as transmission productive scheme as well as a distributed distribution productive scheme. Different types of productive schemes are there. So we, in this for our analysis, we are considering an overcurrent productive schemes. Overcurrent productive scheme. So on that overcurrent productive scheme, on that we have using some circuit breakers to clear the fault. For the circuit breakers, we are using some relays. Okay, so how this relays will behave based on this overcurrent productive scheme relays will behave based on this one. We can see this. We can our approach is on this three ways. First one is the reduction of the reach. First one is the reduction of the reach. First one is the reduction of the reach. Then second one is the some tripping of the circuit breakers. Okay. Then third one is the defeat of fuse saving. So you see this three different categories where we are going to examine in this one. So three different categories. So reduction of the reach. What is this meaning of the reduction of the reach? What is the meaning? Then what is the tripping of feeder breakers? Sympathetic tripping of this feeder breakers, nothing but circuit breakers. Feeder breakers means so you know that we are connecting our releases to the some distribution feeders and different types of the feeders. So and also that's why we can call it as the feeder breakers. Then what is then third one? So defeat of fuse saving. So now we are going to see this. First one, reduction of reach. We are going to see the reduction of reach. So as you come to the again back, yes. Now we can call this type of the scheme. As I said, a generated productive scheme is productive lines. You can call it as a zones of protection. Zone. This is the generator zone. Zone of protection. Zone of the protection. Yes, this is the generator zone, this is the transmission zone, this is the distribution zone. So this we can regard as this type we can regard as zones of protection schemes. So generated protection scheme, transmission, distribution. So we can simply regard as zones. So this is the generator zone. This is the transmission zone. This is the distribution. Okay. Now we are concentrating on this distribution side protective scheme. Now see this diagram carefully. Okay, we can see this diagram carefully. So now we can observe this as a draw in red color. Yes, see this this red color circle. You can see this red color carefully. Yes, see this. Yes, yes, this is this red color circle. You can observe this one. You can observe this one. This is the actual, like this is the actual, okay, zone of the production designed by the and productive engineer to protect the systems from the external faults or internal faults and all other things. This is the work on relaying protection. So this is the actual, remember, this is the normal or actual zone of protection is like this. Remember this one, this one, this one, this one, this one, this actual, this is the size, and this is the total distance to protect the distribution system. But because of adding, remember, but because of adding, which one, as dg, yes, see this dg, because of adding this dg, yes, this dg, see this, because of adding this dg to the feeder, the productive scheme, the area, the range, or you can also call it as the reach. So now see this. So whenever, now see this red lines, red circles. Okay, once again see this red circle. So in this area, there is any fault is occurred in this area. So that's the relay is detected that fault and given the commands to the circuit breaker. According to the circuit breaker is operated. Remember. So in this area, you can see these red lines in this area, in this covered area. Okay, in this covered area, there is any type of the fault is occurred because of some short circuit and all other things. Because of we are considering only one fault, a work on protection or work on because of short circuit and all other things. So in this area, any type of the fault is present, it will be sensing that relay and given the instruction to the circuit breaker. That is the uh, principal protective scheme. Now see this. Now see this. Any in this covered area, any type of the fault is occurred. So that is sensing by that different types of the relay and given commands to the circuit breaker based on that circuit breaker software. Once we add, remember this point carefully. So once we add these DGs to this feeder, okay, what will happen here? What will happen here? The range, okay, we can see this green color, the range, you can see this green color, the range of that relay, the sensing range of that relay is reduced. So in this in electrical terminology they can call it as a reach. Okay, if you are not confusing that one, the meaning of that one is reach, the reduction of the reach. That means the range, the fault identifying range of that relay is reduced. Okay, that we can call it as a reach. Now see this reach of the relay. So this is the actual. Now see this red line, this red circle, this red dotted lines. This is the actual range of the relay to detect the fault. But because of infusion of this DCR, because of adding these DGs to this feeder, what will happen here? The range to detect that relay is reduced. Remember the reach nothing but the detective area is reduced. Okay, so what will happen here? So there is any you see this fault here, there is any type of the fault is occurred in this region, so the relay is not able to detect that fault, the actual this one. But here because of adding this one, it is reduced, the area is reduced. There is any fault is occurred in this any empty area, so in this area you can see this I can change the color. Some in this area you can see this in this area, so see this in this area yellow color, can see this yellow color, there is any fault is occurred in this area, so relay is not able to detect that fault. What will happen here on that case? The system may damage. Okay, system may damage. So why so so why what is the reason why this area is reduced? Our question is that we are going to learn how this area is reduced because of adding this DC. So because of adding this disease to this area, the current identifying, remember, the relay identifying current range is reduced. The DC in feed can reduce the current that relay sees, remember, because the point is here. This is the important point. Why? Because the current. Okay, so the current that identify that relay, so amount is reduced because for suppose our relay is designed to protect in this red lines area, so that current is for suppose of some nearly some 100 amperes. For suppose you can assume that that as a 100 amperes, 100 amperes. Because of this DC infuser to this feeder, what will happen here? So the amount of the current is reduced. Here the DC current detection is reduced, nothing but reduced to the some 80%, some 20% is reduced. For suppose 80 amperes. The 20 amperes, what will happen? This 20 amperes range is remaining left. So in this area, if there is any fault, you may get damage the system. Okay, you can see this point carefully. So the DC input has the potential to mask many faults that would be observed to detect the solutions. So how to overcome this? How to overcome this problem? How to overcome this reduction of reach? Nothing but how to overcome this relay detection problem. How to overcome this? Okay, so first one, we have some solutions are there. We have three different solutions, three different types of solutions are there. First one, decrease the relay minimum pickup current to increase the zone. What is that one? Decrease the, you know, that relaying concept, how does it how that relay is operated. If there is any deviation on that measured current levels, okay, the relay is sensing that current level, that actual current level as well as that fault current level, and giving the information to the circuit. So for that type of relay, you can decrease the minimum pickup current to increase the zone. So for suppose here what is the pickup what is the pickup time here? What is the pickup time here? 100. For suppose it is the 100 amperes is the normal. What is pickup time more than that 100, greater than that 100? For suppose 110 volts. For suppose I'm just assuming, I'm just at 110 volts, sorry, 110 amperes, sorry, 110 amperes. So you get this 110 amperes. So the relay will activate that one and clear the fault. But because of that, what will happen here? This reach of that relay is reduced to the below 80 amperes. Below 80 amperes. We are setting 110 amperes, but reach is reduced to the below 80 amperes. So that's why you are setting our relay ranges to operate is nearly less than or equal to the 80 amperes. Less than or equal to the 80 amperes. Do you understand? So initially, before adding this thesis to the system, we can set the parameter value to operate the relay is more than 100 amperes. An example, this is an example, 100 amperes. First of all, we can assume it as a 110 volts. If it reaches to the 110 volts, the relay will detect that fault and clears the fault. But because of this DC, this reach value is reduced to the relaying, the total amount current value is reduced to the 80. So that's why you can decrease the relay reach value to the less than 80%. So then there is no problem at all. So below the levels we are setting that relaying pickup time. So that's why there is any problem below that 80 amperes, so it will suddenly so nothing but the relay reach value is now 80 amperes only. Here 110 amperes you can reduce to the 110 amperes to the 80 amperes. You can reduce that one. So there is any changes, the relay will detect the two. You can have it. At the same time, well, that is the first one. So what is second one? Add a line recloser to create another protection zone that extend for fast and end of the field. So another yes, to read and another recloser. So here in this region, you can connect this among the recloser to protect the system. So then what is the third one? Use transformer connection that minimizes DC contribution to ground faults. They are transformer connection. It is how this DC will connected in this species point by using some transformers and other things. So that's why you can reduce the high impedance faults likely to the grounding faults and all other things. So these are the three cases to avoid the reduction of the reach. You know that whenever an impedance is increases in the system, what will happen here? The relay performance is changes. Uh, so that's why. So whenever you are connecting through this DCs to the any transformer, okay. So that may we are going to reduce this impedance faults and all. Okay. Okay. This is the case. Now, sorry. Now, what is the second one? Here, the first one, reduction of the reach. What is the second one? Asympatic tripping of feeder breakers. Feeder breakers. You can see this feeder breakers. You can see this diagram. You can see this diagram carefully. A small. Again, once again, they can consider the source here. This is the substation. So the substation can assume it as a this is the US system substation, 12.47 kV and other things. This is the feeder one. So this is the feeder one. This is the feeder two. We are connected 2 megawatt DC. You know that a DC is range is below 10 megawatt only. You can assume it as a DC. Any generating plants that is nearer to the load locations. At the same time, the capacity of the plant is below the 10 megawatt. On that type, you can call it as a distributed generating plant. So here in this feeder 2, we are going to connect the 2 megawatt plant near to the load locations. Now, what is this systematic tripping and relaying and all other things? You can see this. What is systematic tripping is describes? You can see this one. So this describes a condition where breaker that does not see false current strips. In this one, so the breaker did. So the most common circuit condition and utility distribution filter is backfeed into the ground fault. So now see this. Most of the feeders doesn't have any directional sensing equipment and other things. So so we can see this. Now the main problem is there is no directional relays to sense the fault currents to detect that faults and to open the circuit breakers and other things. So the tripping of the circuit breakers, there is any tripping and other things. Okay, so different categories and tripping and all. We can see maybe time is running out, so you can see in next class the sympathetic tripping of circuit breakers, how this circuit breakers will trip, there is any problem in the tripping of circuit breakers, so and all other things, how the circuit breakers will not why the circuit breakers will not trip because of some additional these diseases. So we can see this delaying. So the same problem is also facing the fader circuit breakers also. Now we are going to see next class. So I hope you understand this one. So this so reduction of the reach. Okay, so next class in this inference relaying only the second one. So tripping up the fader breakers and defeat fusion saving we are going to discuss in the next class. Okay, yes, thank you for joining today's class. Thank you very much.